Well, how is it all done, I hear you ask? The answer is in the Hornby reference manual, which is available to download as a PDF from Hornby's website. On page 119 of the reference manual, there is this diagram which shows you how it's done. It shows here that there's the connections to the DCC controller and a diode matrix. All diode matrix is this. That's all it is. It's just all you've got to do is just connect these diodes in the manner they've suggested in this diagram here. There you are. Underneath the layout, the diode matrix is connected through these connectors. And they lead up under the baseboard track. It connects here when there's a break in, where there is a break in the track. It's important to note that you don't need more than one diode matrix, because the same diode matrix can control both tracks, because you're on DCC and the whole circuit is electrified. It shows the physical layout of the diode matrix. You've got one diode here and 4 diodes there. They face in different directions. This side is the anode and this side is the cathode. The cathode is marked black on the diode itself, and the anode is marked in red. So if I put this here, which is in the same way, you can see that it's red at one end and black at the other end of the diode. So it's quite easy just to fit these diodes to a chop block to make the diode matrix. In the reference manual, Hornby suggests you solder the diodes together and fit them into a box with a switch, but I don't advise you to do that, because if any of the diodes fail, then you've got a desoldering job to replace it. It's not really necessary to fit a switch. You can just unplug the diode matrix and just fit another connector which has been shorted out. Just plug that in like that, and there you are. And then the diode matrix is gone and the circuit's returned to normal. These are the type of diodes shown in this manual, but I would advise you to use 1 amp diodes, which look like this. The type of diode you use doesn't matter very much, and in fact it does look in this illustration as though the 1 amp diodes have been used. This type of connecting rail is R618 from Hornby. Are these green switches which can be used to short out the diode matrix if you don't want to go to the bother of physically removing it. This type of connector, that just plugs in there. Yes, it's very easy to make a diode matrix. There we are. If you don't want to go to the expense of buying the Hornby isolating track, you can buy these R918 insulating rail joiners from Hornby, and you can use one of these Pico rail joiners. These are very similar to the Hornby ones, except they're much easier to solder to. If you go into a model shop, you can get the Pico rail joiners, and then of course you just wire that into your system. How it works is a train comes around the track and gets the brake in the rail, and that triggers the automatic braking sequence, and then as it comes along here it slows down and stops at the station. There is another insulating rail joiner here, you would hardly see it. Pico make insulating rail joiners, but they're very noticeable when fitted to the track. They're much larger and more noticeable, so the Hornby ones are less noticeable. You wouldn't notice it was there. On this track, the insulating rail joiner is here, you can hardly see it. It has to be at this distance because there's got to be enough room for the train to come to stop before it hits the buffers. Wherever you fit your insulating rail joiner, you've got to allow more room than is necessary, because the stopping distance is usually out by about 6 inches. The stopping distance is set in a CV in the app. You have to determine what the correct stopping distance is by trial and error. There are several options. One of the options is to use the acceleration or the deceleration CV. The other option is to use the factor as set in CV127. So you have to do it by trial and error to work out what is best for your particular loco. Also of interest is this smart screen. It can be programmed to change what is displayed when the train goes past a sensor. The sensor is here and is showing a red indicator indicating that it is connected to DCC and is working. What we will do now is set this train going and see where it comes to a rest. Yeah, I can hear you. Off he goes. Here he comes. In a moment he's going to go over that sensor. The display there will change when he goes over the sensor. Yes, it says train approaching. So you can have a lot of fun with that. He is indeed approaching. Let's see if he stops, shall we? I stopped and he starts again, so it proves it's all working. I hope you've enjoyed this channel. If you enjoyed this video, please leave a like and please leave a comment. Bye for now.